How do you think about sleep as it relates to learning and memory?
I think I've conceptualized it in three different stages or three different buckets of a benefit. The first is that we need sleep before learning to prepare your brain to initially imprint and lay those memory traces down. But then you need to sleep after learning to take those sort of freshly minted memories and then save them and cement them into the brain so that you don't lose them. The third domain is that sleep will then take those new memories that you've been learning and it will start to collide them with all of this back catalog of information that you've already got stored in your brain. And it updates the iOS of your informational systems so that then you come back the next day and you have a better abled ability to understand how the world works. In other words, the difference between knowledge, which is learning the facts, and wisdom, which is knowing what it all means when you put it together. That's the third category. And why is that beneficial? Because it provides you with creative insights. We started off asking a very simple question at my sleep center. Is pulling the all-nighter a wise idea? So we took a group of perfectly healthy, smart individuals, and we assigned them to one of two experimental groups, a sleep group and a sleep deprivation group. And both of those groups went through those two different protocols. And then the next day, after sleep or after no sleep, we put them inside of a brain scanner. And we had them try and learn a whole list of new facts as we were taking snapshots of brain activity. And then we tested them to see how effective that learning had been. When we looked at the group that had had a full night of sleep, they had incredibly efficient learning capacity. So in other words, they had learned and imprinted that information initially very well. When we looked at the sleep deprivation group, not so much. In fact, there was a 40% deficit in the ability of the brain to make new memories without sleep. And we've used lots of different types. We've replicated that now. We've had visual information. We've had textbook-like information. And the range is somewhere between 20 to 40%. I find that, by the way, striking, and we can come back to this, based on what we are seeing in our educational systems right now. There is this paucity of sleep because of this model of early school start times. And I'll explain exactly what's happened there and what we've been doing to try to change that. But coming back to those two groups, the sleep group and the sleep deprivation group, what was going on, as you said, inside of the brain that would help us understand why they couldn't learn, or at least couldn't learn effectively? And the structure that we focused on is one you've spoken about before, called the hippocampus. And you have one on the left side and the right side of your brain. It looks like a long cigar that runs down the left and right side of your brain. And people listening can think of the hippocampus almost like the informational inbox of your brain. It's very good at receiving new memory files and then holding on to them. And when we looked at that structure and its activity during learning in the sleep group, they had wonderful, powerful activation of the hippocampus as if it was gobbling up all of that new information into the inbox. When we looked at the sleep deprivation group, however, we couldn't find any significant signal whatsoever. So it was almost as though sleep deprivation had shut down the memory inbox, and any new incoming files, they were just being bounced. You couldn't effectively commit new experiences to memory. And then subsequent studies that were not done by us, but looking at animal models, they were looking at how able the synapses are in that memory structure, the hippocampus, how capable those synapses are for building new connections. And the synapses are just those connections between neurons. And we think that part of the way that we make memories is by strengthening the connection in the memory circuit itself. And what they found was that when they restricted the sleep of these rats or the mice, that part of the brain became very stubborn. It just wouldn't form those new synaptic connections. It's something that we call synaptic plasticity. So we started to understand this was the bad that happened when you take sleep away. But let's come back to that control group that I said got a full night of sleep. Exactly what is it about sleep when you do get it that seems to support and promote your learning ability? So we decided to do another different study. Instead of manipulating sleep by dialing it down, we instead tried to dial it up by way of a daytime nap. And again, we took two groups and we had them initially learn, again, a huge amount of factual information. They learned it over and over and over again. And then we brought them back 6 hours later at 6 p.m. And now we had them learn a whole new set of information. And after each one of those fresh, novel learning sessions, we tested them to see how effective that learning had been again. One of those groups spent that 6 hours of time awake, doing just relaxing activities. The other group was able to obtain a 90-minute nap. And we used that 90-minute nap to allow them to go through a full sort of average cycle to get some non-REM and to get some REM. What was interesting is that when we tested the group that remained awake later that following day, their learning capacity had declined. But in the nap group, it seemed to restore the brain's capacity to learn. And you didn't get that decline in memory. In fact, if anything, you got a little boost. And the difference between those two was about 20%. So it's quite a nice benefit.
Yeah, not trivial.
Not trivial at all. And then we said, okay, well, if sleep is doing something, what is it about that sleep? So we unpacked the physiology of sleep and the different stages of sleep that we discussed in the first episode. And what we found was that it was the non-rapid eye movement sleep, or the non-REM sleep, and particularly those sleep spindles, those short bursts of electrical activity that we have discussed before, that seemed to predict how restored and refreshed your learning ability was. And the best way that I've been thinking about this in terms of sleep restoring or refreshing your encoding ability, and it's a crass analogy, and I don't mean to make a direct brain to computer analogy, but think of that hippocampus almost like a USB stick. That it's very good during the day at going around and grabbing new files, but it has a limited storage capacity. And what sleep was doing seemed to be shifting those memories from the USB stick of your hippocampus over up to the cortex, which you can think of almost like your hard drive, a much bigger storage capacity. And by way of doing that, when you woke up after the nap or after a full night of sleep, you had this cleared out USB stick. So what could you do? You could go around and start acquiring all these new files again. So that started to teach us a little bit about why sleep before learning is critical, but also mechanistically how sleep is doing this remarkable work of memory restoration.